abdomen, that's the helix. It shows you the adrenal glands, the kidneys. They usually never ask you anything about here because they have such great models over there, so don't study that. But they will study this. You have the ureters, you have the alien, which is the bladder. This is called the alien because it has a bladder, and then right below the bladder it has a beak. Well, this beak happens to be the prostate, so this is a male urinary bladder. This is a seminal vesicle, and this is the vas deferens, which you're going to learn about maybe a little bit today, more on Wednesday. But what you can see here is if you take this away, you can actually see the inside of the bladder where it shows the rugae, and then it shows something called the trigon. Remember we studied, I think the trigon? The opening of the urethra and the two ureters make a triangle. That feel good? And so the trigon is this tissue area here. It's actually different tissue. It's kind of linear granular tissue to help whatever is in the filtrate that is not liquid particulates settle down to the bottom. They kind of go in these little grooves, and they all kind of fold into the opening of the urethra. So this is the membranous urethra, then it goes through the prostate urethra, and eventually gets into the spongy urethra. The red line on this is represented the detrusor muscle, which is one of the contractile muscles, the smooth muscle in the urinary bladder. You have to know detrusor muscle?
Yeah.
Okay. So that's about all this model shows. So be aware that this is a male model. This is the prostate, which makes that the prostatic urethra, rugae, detrusor, the trigon you can see in there. So here, the trigon. Okay. And the urethra structure, seminal vesicle, as well as the vas deferens or the ductus deferens for the reproductive system. They sometimes will throw this in. They might ask you, like, what is this? And you'll say,
Inferior
vena cava, right? Karina? Okay. And Karina, you'd say this is the
descending.
What's the other part of that?
Abdominal aorta.
Yes, that's right.
Or that.
All right. So this model is fairly straightforward, nice and easy.